Hi, I'm here with my daughter, and we're going to learn a little bit about some electrical circuits, in particular the resistors. And first, let me introduce my daughter. This is my daughter, Heather. Say hello.
Hi.
Speak up so they can all hear you at home.
Hi!
Okay. Anyway, a few weeks ago, she went to a little science day at Wentworth University, right, in Boston, with the Girl Scouts, and you had some fun. Okay, you did a lot of stuff.
Yeah.
Okay, so one of the things that she was very excited about was this. She made a little circuit. Okay, so it's a game, and why don't you explain to everybody what it is?
So it's kind of like operation. So you have to get the ring, this, all the way over to here without the lights lighting up.
Okay, so why don't you show us how it works? The lights lit up. Okay, so you start at the bottom. I just saw it light up. Okay, so what's happening is when this metal ring touches this, okay, it then completes the what?
Circuit.
It completes the circuit. I mean, remember that they're at home watching us. It completes the circuit, and that makes these light up, right? Okay, so do you remember what these are called?
LEDs.
LEDs, yes. Light emitting diodes. So a diode is a part of a circuit, a little component, that allows electricity to go in one direction. Okay? So when the electricity connects, when these two metal pieces touch, then electricity goes through the circuit in one direction and causes these to light up. Okay? So what happens if I turn this diode around?
Then no electricity will go through.
Right, no electricity will go through, and
Both of them
it won't, what?
complete the circuit.
Yes. Okay, it won't complete the circuit. So, do you think it'll light up?
No.
No. No. Because now the electricity is going in the wrong direction. So the diode will only allow the electricity to go in one direction. Okay. And at the beginning you have this piece of tape, okay? And the piece of tape is so that you have a spot to begin, right? And the piece of tape acts as a what?
Insulator.
Insulator, yes. Okay, so it doesn't allow the electricity to pass through from the metal ring to this metal, looks like almost kind of like a paperclip material. Okay? And then you have one here, so that when you get halfway around, you can take a break and go, I'm halfway there, and then continue on, right? Okay, excellent. So, this is a pretty simple circuit, okay? It is made up of what? A battery,
wires, LEDs, a
little thing that looks like a bean, because with an R, I just said it about 5 minutes ago.
retractor.
It resists the electricity. Yes, a resistor.
And a
okay.
paperclip thing.
And yes, a paperclip type thing. Okay. So the resistor, okay, well, do you know what the resistor does in the circuit?
It resists the electricity going to the light bulbs.
Yes. Okay, so what does it do to the electricity?
It slows it down.
It kind of slows it down, exactly. Okay. So you might see on this resistor that we have some color bands, right? Okay. The color bands will tell us what value this resistor is, how much it will resist. Okay. So what's the first color band?
Yellow.
Okay. So yellow is a 4. The next color band?
The purple.
Purple. Yep, what they call violet. So 7. Okay. So 4 and 7. What's the third color?
Third color is like a brown.
Brown. Okay, so brown means that you multiply it by 10. Okay, so 4 and 7 is what?
47.
47. Okay, times 10?
470.
Yes. Okay, so it's 470. So a resistor is measured in something called ohms. Okay, and it's just, like inches or, degrees, temperature, whatever. It's ohms. Okay, so 470 ohms. Okay, I have another resistor right here. Okay, what is the value of that resistor? Using the handy dandy chart, can you figure it out?
Okay, so 47.
Okay, because it's purple and yellow.
Yeah.
Yellow and purple.
Yeah,
Yellow and violet.
and that one.
Yep, so 47.
47.
And then the third band is what? What color?
Times 10.
What color is the third band?
Yellow, so it's times.
The third band?
Oh, orange.
Yellow, violet, and orange.
Orange. Times 1 is 47.
Times 1 what?
K.
1K. K stands for 1,000. Okay?
So
So what's 47 times 1,000?
47,000.
Yes. Okay?
And then silver.
Okay, so it's 47K.
Yeah.
So, is 47,000 bigger than 470?
Mhm.
Okay, kind of a lot, huh? Okay, what do you think will happen if I put a larger resistor in place of this?
The light bulbs would light up more.
Okay, so a larger resistor will make the electricity go even slower.
Oh, so it's lighter.
Okay, so the LEDs will light up more or less?
Less.
Less. So if there's less electricity going in, they're going to light up less. Okay, so that's how they look with that resistor, right?
Mhm.
Okay, why don't we just leave that? Okay, now I'm going to put in the other one.
Do you want to take out the battery?
And see, they light up much less.
Mhm.
Okay,
And I should take it.
and of course if you take it out, the circuit isn't completed. So you put that one back in and they light up again.
What about those
Okay,
ones?
now this over here,
Mhm.
okay, this I have it just soldered up to some wires to make it easier to plug into this thingy. And what's this thingy?
Breadboard.
Breadboard.
Yay, breadboard.
Yes, yes. And she was kind of amazed that when she came home, I had a breadboard, here at the house. She had no idea I had one. But anyway, so what I'm going to do, okay, is I'm going to put this, okay, this is a potentiometer, okay, like a knob kind of a thing, okay. It's a variable resistor, so that means the amount of resistance we can change by turning the knob, okay. So if I plug it in, okay, actually I'll plug it in the other way. So that turning, okay. So now we have a variable resistor, okay? So I can change the amount of resistance, and that slows or speeds up the electricity going in. Okay, so here, why don't you try it? Okay, so there you have the most amount of resistance, and now you have the least amount. So the most makes it go dimmer. Okay? That's kind of neat, isn't it? So with a resistor, you can change the amount of electricity going through the LEDs, and that lights them up more or less. Okay? So if you wanted to, say, have this game, okay, only light up like a little bit like that, okay? And, why would you want it to only light up a little bit? Okay, if it lights up a lot, do you think it uses the battery up faster or slower?
Faster.
Faster. Okay, so if it lights up really bright, it's using the battery a lot. So you might want to make a game where the battery will last longer. Okay, so you might turn it down a bit. Okay, so what you can do is turn it down. Don't touch the knob anymore. Take this out of the circuit. Measure the amount of resistance, whatever the amount, because it could be 0, it could be, 1,000, whatever. Measure the amount that this is set at. Find a resistor.
But how do you do that?
Oh, you're asking everything. Okay. Well, you would do that with this thing. Okay, it's a multimeter. Okay, so what we'll do is we'll set it to something. Okay, and these little metal pieces here are just the same as touching the ends of the wires. Okay, so rather than trying to touch the ends of the wires, I can just touch these. Okay, so I could do that and that. Okay, so what resistance do we have? Can you read it upside down?
241.
24.1. Okay, so 24. You could just round it.
24.
Okay, so that would be the amount. If you wanted it, say, a different amount, I just turned the knob a little bit. Okay. Now it's what?
42 and 4.
42.4.
Yeah.
Okay, so that might be the amount you use. So that's how you would check the amount of resistance on the potentiometer here. Okay, does that answer your question? Okay.
That is loud moving.
Yes. So there we are again with the circuit just how you had it. Okay, and we could even add another light bulb. Do you want to do that?
Yeah.
Okay, so you're going to unplug this. Okay, and using the breadboard makes it really easy to plug different things in. Okay, and we want to make sure that we have it oriented the right way.
The curly side is the longer side.
The what?
The curly side is the longer side.
Oh, okay, the curly side.
Rudolph, but with red eyes.
Oh, yeah.
And
See, it looks like red eyes and a green nose.
Rudolph the green nose reindeer.
Okay, so we could actually string a bunch of these LEDs together and have it light up a whole bunch. So all we're doing is just having the circuit, having the electricity go into the first one, light it up, out of the first one, into the second one, light it up, out of the second one, into the third one, light it up, out of the third one, and continuing on through the circuit. So we could have, 2, 3, 4, 5. We could have whatever we wanted. Okay? We could wire up a whole bunch and actually like spell out words or something. So maybe you could like spell out, you stink. So when they're doing the game and they're going, okay, 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 almost got it, and then they go, it lights up, you stink, or you lose or something. That would be funny. So anyway, that is the little circuit that my daughter made. So say bye to everybody at home. Hope you guys learned some stuff about circuits and resistors and everything. And it's super important to, teach your kids all kinds of stuff, including science. And hopefully this helps some, people teach their daughters and sons too about things like science and circuits. So, thanks a lot. Bye.